A huge number of bacteria have been described, many of which are dangerous to humans. To fight bacteria, you need to know their weakness. From a practical point of view, this question is important. Are there common signs based on which we can predict the sensitivity of bacteria to an antibiotic? Indeed, there is such a sign, the bacteria's structure. The action of an antibiotic on a bacterium is a biochemical process, with each of them having a point of application, a certain chemical substance, which is the bacteria's structural element. Bacteria, having the same structural element, for example, the protein of the cellular wall or sets of enzymes, will cause increased sensitivity to the same antibiotics. There are three main things which differentiate a bacteria's sensitivity to an antibiotic: their form, which are cocci or sticks, the gram stain, which is positive or negative, and their oxygen consumption, meaning if the bacteria is aerobic or anaerobic. There are a huge number of combinations, but from a clinical point of view, four main groups of bacteria can be distinguished, showing the same type of sensitivity to antibiotics. These are gram-plus cocci and gram-negative sticks, or rods. The majority of infections are attributed to these culprits, with a majority of antibiotics as well being utilized against them. In addition, the anaerobes and intracellular pathogens are a bit less common. The main representatives of the gram-plus cocci group are the Staphylococci, Streptococci, and Enterococci. Staphylococci lead the way, causing most of the infections, in particular infections of the skin and soft tissues, bones, joints, and even respiratory infections. The greatest danger to humans is Staphylococcus aureus, which is literally golden staphylococcus. There are many streptococci, but the most prominent are beta-hemolytic streptococci and pneumococcus. They cause respiratory infections, including pneumonia, rheumatic fever, bacterial endocarditis, and erysipelas. While enterococci, they cause urogenital infections, meningitis, and bacterial endocarditis. Next major group are gram-negative rods. They include E. coli, Proteus, Salmonella, Shigella, and Klebsiella. There is no need to memorize them all, because family sensitivity is the same for the whole group, with the exception of Klebsiella, with its special protective functions. In other words, prescribing an antibiotic that's aimed at E. coli, we can be confident that they will affect the before-mentioned bacteria, besides Klebsiella. The other representatives would be Haemophilus influenza, which is a gram-negative rod that causes respiratory tract infections. The second part of the name, Haemophilus influenza, means influenza, which is associated with the initial isolation of this pathogen from sputum in patients with influenza. Pseudonomus aeruginosa is a causative agent of pathogens with mass options that can cause diseases in adverse conditions. Causes nosocomial infections, which are healthcare-associated ones. In hospitals, it lives in water, in air conditioners, sinks, ventilators, and in addition, the hospitals don't have much bacteria, as they're eliminated via antibiotics, but Pseudonomus aeruginosa lives on. Now the next major group are anaerobes. These include bacterioids, Peptostreptococci, Fusobacteria, and Clostridia. They cause intra-abdominal and pelvic infections, gas gangrene, or there's another representative, Propionibacterium acnes, which, if you could tell, causes acne. And the last one would be intracellular pathogens. They are characterized by the fact that they do not have a cellular wall and they are not affected by inhibitors of its synthesis, which are beta-lactams as well as glycopeptides. As a rule, they are inside the cells of their prey. These include chlamydia and mycoplasma, which cause sexually transmitted infections and respiratory infections, such as pneumonia.